Hello, YouTube viewers. Welcome to my show, Future Friday, episode number 4. Today, we're gonna take a look into Hell, or colloquially known as Venus. So, let's get started. So, what is it? It's a planet same like Earth, Mars, and Mercury, and it's a terrestrial planet. Basically, it has stone core. Basically, it's not a gas giant, it has a surface. It's based on stones, and it's the second size planet, as in like Mercury, Venus, Earth, Mars. So Mercury is at the second ranking from Sun. Mercury, Venus, Earth, Mars. Now it spins backwards, and it's little smaller than Earth, and I will dive into it why that is such a good thing. And it can be seen as with naked eye, and you must have heard morning star, evening star. That's this Venus. Yes, that's a planet. You can see it quite easily, and you can download mobile apps to aid your discovery of this morning star. So, what's it like there? Well, day is longer than year. What does that mean? One day can go longer than a year. Actually, it spins so slowly that its day literally is over until one orbit is finished. So, suffice to say, instead of 24 hours, it has like around 5,000 to 8,000 hours or something like that. So days longer, and it's actual hell. So imagine lead, a metal that you have in lead acid battery and other things. Imagine melting that would be the surface temperature of Venus. Now the magical part, that's why I have highlighted this, it has 90% of Earth's surface gravity. So if you stand there, of course in a chamber where you can stand, it will feel almost like Earth. Like unless somebody told you that you are on another planet, you won't be able to tell it because the gravity is almost same. On Mars you will easily know that the gravity is way too low, but on Venus it's almost the same. It has a lot of sulfur in it, basically sulfur dioxide in clouds. So basically you have to have acid resident thing, otherwise you're gonna be corroded away. So it is actual hell, and all that thing might be manageable, but it also has an atmosphere that's 90 times of Earth's. What does that mean? Basically, if you send probe down there, it will be crushed by the atmosphere itself. Like how you can send some like a ball or something like in deep ocean, it gets crushed by the water pressure. It has 90 times the atmospheric pressure. So Earth can be classified as 1 bar at sea level. This puppy has 90 bar. However, all those things can be solved, but this does have the magical part that it has 90% of Earth's surface gravity. So let's understand why it's so important. So if it is like a hell, then why it's so important to humanity? Well, the question came to mind, people, once we sent the first probes to, this was the first planet that our probes went to, and we found it something odd in it, that Mercury, Venus, Earth. Mercury should be hottest, and it is. Like its day side is as hot as roughly 350 to 400 degrees Celsius. However, because it does not have an atmosphere, the night side reaches almost absolute zero. Okay, cool, makes sense. However, Venus, it's 400 degrees, which is already higher, and it does not have a night side. How the heck a planet that is further than the source of energy is hotter than what is closer to it? That's what taught us about runaway greenhouse effect. This is why humanity knows of greenhouse effect. We did not learn about greenhouse effect on Earth. It's learned from Venus. Suffice to say, it's quite important, and this is a very basic representation of greenhouse effect. All you have to understand is that Earth absorbs energy and ejects that energy. Nothing fancy about it. It's like how you heat up a glass of water, it cools down. As simple as that. Sun is the heater, and on the night side it cools, it gives off the energy. Now, tricky part is that CO2 reflects infrared. Not all spectrum, not all wavelengths, but infrared specifically, certain range, it reflects it back. Now, it acts as like a mirror, where like Earth got bombarded by high energy radiation. Earth got hot, it's like okay. At the cooling time, it's releasing that energy, but it's not releasing in the same frequency. It's not like releasing ultraviolet. It's releasing infrared. It's like the heat that we feel. It's trying to cool itself. However, the CO2 in the atmosphere that we have added, it's reflecting it back. So it's acting like a blanket. However, this blanket is not two-way, it's one-way. That's the biggest problem with it. It's not that on the sun side it's not gonna work. Sunlight won't be reflected off of it. It will still come inside, but it will get trapped. That's how Venus got so hot. That is the biggest problem with greenhouse power. It can lead to a runaway, and once it runs away, yeah, planet is dead. So Earth has the potential to turn into Venus. Although our temperature might not reach 400 degrees Celsius, I mean, like, proximity to sun does play a role, but 150 degrees Celsius is quite achievable, and suffice to say, you really don't want that. Venus is the reason we know of this. So the importance of Venus cannot be understated. Now then question comes to mind, why I am so excited about it. The good. Now we learned it's hell and all that, so what's the good about it? It's actually terraformable. In the episode on Mars, I specified Mars cannot be terraformed with any current technology. This, however, this is an artist rendition of Venus, how it could look. Of course, it's an emotional artistic rendition, but it is feasible to do that. All you need is mirror. Now you have to understand, in a two-body system, basically where there is a star and planet, we have what's called Lagrange points. Basically, if you put a spacecraft there, it has to spend very little fuel to keep itself steady there. Now basically we have to put a sunshade, basically mirrors, at Lagrange 1 point. Now of course you are trying to shade a planet, it's not going to be small mirrors, it's going to be hundreds of kilometers large. Now it won't be one large mirror, you can't build that, you will have hundreds of small ones, and we have done testing on this sort of thing. We also call them solar sail. So we know it's feasible, and the only way to do it on a planetary scale would be if we colonize Moon, and I have already made an episode on that. So it is terraformable with only mirrors. So you put a mirror here, it cools the planet down. However, it does take time. This is not something we put a mirror, tomorrow the temperature will go down. It will take time. 200 years of time. Now you're like, whoa, that's too long. Yes and no. Yes, it's too long. No, it's not too long, because that's few generations. That's not like hundreds and thousands of generations. That's just, there are homes that are old enough. There are temples that are older than that. Heck, Roman civilization lived 900 years continuously. So suffice to say, it's not raw. And what are you getting at the other end? This is the miracle part of it. You are getting Earth 2.0. So let's say you blocked it. Now you might ask a question, okay, I have blocked it, cool and all, it's cold now, but there is no sunlight. Now we have to put mirrors in L4 and L5. What they will do? They will bounce the light into one sphere. Ideal material for this would be tungsten, and tungsten will start to glow, and we can make the tungsten ball basically a satellite. We are just making an artificial satellite which uses mirror here and here to reflect sunlight to that ball, and we'll get a day-night cycle. That's how we can bypass this a day is longer than year problem. So suffice to say, with mirrors only, no magical technology, with mirrors only, provided that we can mass manufacture them on Moon, we got this. For 200 years we can get it. Now it has short travel time, which is very crucial if you want economic up and down between two planets. Mars takes minimum of 260 years, and the first probe that we sent took only 110 days, pardon me. So suffice to say, short travel time. It also means communication is much more faster. You don't, instead of waiting for 20 minutes of lag, you only had 10 minutes of lag, or sometimes even lower than that. So it does play a very crucial role, especially in economics. So, and to make it Earth 2.0, like let's say you got the planet cool down, let's say what will happen to the carbon dioxide that is in the atmosphere? Well, it will either become solid or it will become liquid, because the once you phase change a material, once it gives off the energy, it cannot change back without you putting in the energy. So once we have shielded it, because there is so much pressure in the atmosphere, while it's cooling, it will turn into liquid. It won't evaporate again because there is no energy source to do so. Or if it keeps cooling it down, we permanently block the sun, and we are keep it cooling down, it will turn into solid. When we'll have dry ice lakes basically. But you really don't want to swim in that, because you're gonna die from frostbite, and it's a solid. And you might say, okay, but we are reflecting sunlight to it. But mirrors only reflect a very, very tiny fraction of the electromagnetic spectrum, and if you are not reflecting infrared, you are not getting the heat. You are not reflecting microwave, you are not getting that heat. So basically we are filtering out the entire electromagnetic spectrum. So we are getting the light, the visual light, However, we are not getting the heat of the sun. Of course, the sunshade won't be 100% perfect. It won't be like, stopping it. So that I assume will give us, our seasons, like, when day and night cycle will change. When you come towards the sunshade side, it will be a bit hotter. So it is quite now to make it Earth 2.0. All you did is cooled it down, added it a fake sun. Now, but it still does not have an atmosphere that is suitable for us. We have to add hydrogen to it. Now, this is the tricky part. This is the part which will take a lot of energy and time. We have to go to any moon of the Jupiter, where generally they have hydrocarbon, use a nuclear reactor there. Yeah, solar power does not work that far out, and create a lot of liquid hydrogen. Now, the reason why we want to do that, without it, can we do? Yeah, we can do that. It's just you want to make sure that CO2 does not remain in CO2 phase, because that's a ticking time bomb. We release the carbon in the atmosphere, and carbon got burnt with oxygen, and we have greenhouse effect. So in Venus, we have to make sure that possibility cannot happen. So you have to turn carbon dioxide into hydrocarbon. Basically, we have to pile it up with other carbon. That way we can make into coal, and what will you do with the free oxygen? We will make into water vapor, so it cannot catch fire again. That way we can permanently lock the CO2 problem. So as you see, with all the things that we can do with current technology, Venus has the actual potential to become Earth 2.0, and it will hold atmosphere. It has an atmosphere. Changing an atmosphere is much easier than giving an atmosphere. This is much better candidate for humans than Mars is. Only side effect, we have to put the 200-300 years of effort first. So will it happen? I do not know. However, Mars has trying. Also, you can build flying city there if you want to go today. So that's also there. So that was my presentation. Hope you liked it. Thank you for watching, and if you learned from it or liked it, please like. If you didn't like it, please dislike, leave a comment and subscribe, and if you're free, press the bell icon. I upload video every day, so please do so. Thanks for watching.